Okay, today we're going to do notes for section 2.2. Okay, 2.2 in PAP PRECAL, and this is polynomial functions of higher degree. So we're used to polynomials, and these are just going to be polynomials that may be squared or to the third or to the fourth. And what I'm going to do is I'm going to tell you a little bit about how to identify the zeros and the types of things that you need to know to be able to graph one of these that's not just a quadratic like we learned how to do last year. So this is polynomial functions of higher degree. Okay. Okay, now then, as slow as I'm going, you ought to be able to put these things into your notes. So be sure that you do that so you have these to refer back to, just like you would do if I was standing up in front of you right now. Okay, things that you need to know about polynomial functions and their graphs. Okay, I'm going to list a few things about them, and you need to be sure that you write those down. First of all, they have rounded turns. Okay, you won't see any spikes or points. Everything is rounded, a rounded turn, all of those, okay? So, I mean, it can look like this. That would be polynomial function, but anything like this would be no, okay, because that's not rounded. So it has to be rounded. Also, they're smooth, okay? They are smooth, not broken. Okay, for example, if I were to give you something like this, okay, well, this is not because it's broken. Okay, it can't be broken. It has to be a smooth curve. Right? Even like your parabola, that's still a polynomial. Okay, that's still, these are yeses because they have smooth turns, but they're not going to be broken and they won't have any points in them. All right, so now what I need you to remember, this is really, really important, okay? In your polynomial, if n, and we're going to call that your exponent, okay? So if n is even, okay? If n is even, then the graph y equals x to the n. See, that's going to just be your exponent. So we're talking about n. You check n, you identify that, and if n is even, then the graph touches the x-axis. Okay? It just touches the x-axis as an x-intercept. Okay? Then, if n is odd, then the graph crosses the x-axis. Okay? So if it's odd, it could look something like this. You're going to actually cross the x-axis. Okay, for example, if we had y equals x to the fifth. You see how you cross the x-axis? Whereas if it's even, it could look something like this, y equals x to the fourth. Okay, and you're just going to touch the x-axis. Okay, that doesn't look very rounded and smooth, but it's supposed to be. This thing's hard to write with. All right, so those are some key things that you need to remember that will help you later on when you get ready to graph something. You're going to check that highest power, and that's going to tell you whether you touch or whether you cross. Okay, now then, the other thing that you need to know is what we call the leading coefficient test. Okay, there's a couple of categories, and I'm going to list these in a way that I think will help you remember them. And all this is things to look at in an equation that help you know which way your graph is going to go. Okay, so the first thing you want to do is you want to check that leading coefficient. And here is the case. If that is odd, okay, if your leading coefficient is positive, okay, for example, let me start over. I'm sorry, I think I might have confused you. X to the n. If n is odd.
Please pardon this interruption. Miranda Johnson, if you are in the building, please come to the main office. Miranda Johnson.
And your leading coefficient is positive. So if that highest power is odd and your leading coefficient is positive, then your graph rises on the right and it falls on the left. Okay. Then the next category under n being odd. If that power is odd, then here's the second case. If the leading coefficient is negative, then your graph falls right and rises left. Okay, so let's review that before we go on to an even power. You look at your polynomial and you check that degree. If your degree is odd, then look at your leading coefficient. If your leading coefficient is positive, your graph rises on the right and falls on the left. But if you have an odd degree and your leading coefficient is negative, then your graph falls to the right and rises to the left. So those are the two cases that could happen when you have an odd degree on a polynomial. Now here's the next case. Okay, you could have an even degree. Okay, for example, x to the n, where n is even. And I'm going to do some examples with you in just a second that will help you understand this a little bit better. Okay, so first of all, if your leading coefficient is positive, then your graph rises right and rises left. Okay, and here's your second case. If the leading coefficient is negative, then you fall left, fall right. Okay, so those are the cases that you would have to look at that would tell you how your graph is going to look on each side. All right, so you know you're going to have smooth turns, and you know when you're going to open up, you know when you're going to open it down. This just gives you a few more things to look at. Now let me take a little bit, an example here. Okay, I'm going to write this function down. Let's say we've got negative x cubed plus 4x. Okay, What I'm going to do first is I'm going to decide whether I've got an odd or an even power. Well, that's an odd because of the 3. Okay, you look at that to decide which category you go to based on those last 2 slides that I just showed you. All right, that's odd, so you're going to go to the top category. Now check out your leading coefficient. Your leading coefficient is negative, and according to what I gave you, this is going to fall on the right and rise on the left. Fall on the right and rise on the left. Okay, so in a little bit when you do your homework, you're going to have some that just give you several different polynomials, and you're just going to look at the left-right behaviors. That's what it's called, leading coefficient test for left-right behaviors. So identify whether you've got odd or even, and then after you do that, then you can decide what your behaviors are going to be. Okay, let's do another one. Let's take this one. Let's say f of x is equal to x to the 4th plus, minus 5x squared plus 4. Okay, so the first thing I'm going to do is I'm going to decide whether we have an even or an odd. Well, this is an even, and my leading coefficient is positive, and if that's the case, then we're going to rise on the right, and we're going to rise on the left. Okay, so you can kind of see that in the graph, okay? Rising is going to look something like this. That's going up, that's rising. Whereas falling would look something like that, all right? And of course, that's not the graph for this one because that's going to be more of a parabola shape, but I'm just trying to show you rising is doing this, falling is doing that. Okay? Let's do one more. X to the 5th minus x. Okay, let's identify first. We're an odd again because 5 is an odd number. So we go to the odd category. Leading coefficient is positive. So we're going to do what? Rise right, fall left. Okay, so those are the left-right behaviors according to the leading coefficient test. Okay? Now then, we'll practice graphing some of these in a minute, but I'm going to give you all the notes first. All right, your zeros of a polynomial function. Now, we have just about worn zeros out over the past year and few weeks that we've been here, okay? You pretty much know that when you're going to find zeros, you're going to have to factor. So basically, that's what we're going to look at. And we're also going to look at a few other behaviors that are going to help you graph these, get an idea of how to do that. Okay, so first of all, your polynomial function is going to have at most n minus 1 terms. Okay? Now, n, I'm talking about that highest power. You subtract 1 and it's going to have at most that many terms. Okay? And then you know this one, the fundamental theorem of algebra. Your function has at most n real zeros. You won't have any more than that. Okay? Now then, here's a couple of things that are pretty important to you, and this is based on how we refer to zeros. If I find out that x is equal to some particular number, we'll call it a, then that is a 0. We want to be sure that we're using the correct terminology and the correct notation. If I give you x equals a, that's also a solution. Okay. If I give it to you in this form, this is critical, and you know this, it's just sometimes you don't think about it. Okay, if I give it to you in factored form, then we call it a factor. And you know to get the 0, you have to pull out the opposite sign. But we're going to use some of these in a minute, and it becomes very, very critical. If I give you the ordered pair like this, then that's an x-intercept. Okay, so be sure that you know the differences in all those. The first two are the same. Zeros are solutions. When it's listed as an ordered pair, it's an x-intercept, and it's when it's listed in factored form, we have to change the sign. It's called a factor. Okay, now we're going to do a few more examples using some of the concepts that I've given you. We're going to apply some of these notes. We're going to find the zeros and we're going to graph. Okay, so we're going to graph and find zeros. Okay, so we want to use all those concepts that I just gave you in order for us to do this. Okay, so here's our function. Okay, negative 2x to the fourth plus 2x squared. Okay, so what I think we'll do first of all is let's talk about what's going to happen. We are even, okay, our degree is even, so we go to the even category. We have a negative leading coefficient, so we should fall on the left and fall on the right, okay? So I'm going to put fall, fall. I'm just going to put F, F, all right? Falls on the left, falls on the right, according to our left-right behaviors. Okay, now then, we know that we are going to have 4 zeros, okay? So there's 4 zeros, you know that. Okay, and you also know that you're going to have at most n minus 1. 4 is your leading coefficient, so 4 minus 1 is 3, so you're going to have at most 3 turns. Take 1 off of that. Okay, so you find your number of zeros based on your highest power. That's the fundamental theorem of algebra. We know that. And then your turns, just take 1 off of that highest power. 4 minus 1 is 3, so you're going to have at most 3 turns. Then there's your right-left behaviors. You're going to fall on both sides. Now let's go ahead and factor this, okay? If we factor that, we set that equal to 0. Let's take out a GCF of negative 2x squared. Okay, and that leaves us with x squared minus 1. Okay, and we know that can go further. Negative 2x squared, x minus 1, x plus 1. Now, hopefully that's easy for everybody, okay? Let's look at our zeros. Okay, we have a 1 for an x-intercept. I'm going to list them as x-intercepts. This one over to the right gives us a negative 1. Okay, and we're looking for 4. This one right here gives us 0. And it's a multiplicity of 2. That's what we call that, okay? Multiplicity of 2. Because it's a double root. So there's our 4 zeros. 2 on the 0, there's 1 at 1, 0, and 1 at negative 1, 0. Multiplicity of 2. Be sure that you understand that terminology. Now what we're going to do is we're going to kind of put that on a graph, okay? I'm going to go over here to the next slide, and I'm going to draw a coordinate plane. Okay? And we know that, let me write our function, our factored form down right here. Negative 2x squared, x minus 1, x plus 1, okay? Where you look at 0, okay? Okay, so what we want to do is we want to look at each set of these that gives us a 0. For example, if we look at the negative 2x squared, we know that 0's at 0, 0. We already determined that, okay? So we know that when that is even, it's just going to touch at 0, 0. The graph is not going to go through, okay? Then we know we have a 0 at 1, 0, so I'm going to put that on there, okay? And since that is odd, that x to the first power, we know it's actually going to go through the x-axis. It's going to cross the x-axis right there. Then we also know we have another one at negative 1, and that's an odd power, x to the 1, okay? These are both to the first power. Those are odd, so we're actually going to cross the x-axis at those intercepts, but at x squared, we're only going to touch it. Now, go back to our right-left behaviors. Remember, we had fall, fall, okay? So you know that, first of all, this is an x to the fourth. When we started our original equation, it was negative 2x to the fourth. So it's going to be very, very curvy, and it's going to kind of have the effect of a parabola, but this is more, since you know that you're just touching right here, okay, and you're falling on this side, it's going to look like that on the right, and then it's going to look like that on the left, and it should be a little more uniform. All right, but then you know you're going to cross all the way through. You're going to cross all the way through because that's what your behavior showed. Now you can verify that in your calculator and see that it actually does that, but that's why we know left-right behaviors, and that's why we know if it's odd, it crosses the x-axis. If it's even, it just touches the x-axis. Remember that when you're graphing, okay, that you change signs only at the zeros, okay? Your graph will change signs at the zeros only. Okay? In other words, it's not going to be going from positive to negative unless it's at a zero. Okay? Between zeros, it has to be entirely positive or entirely negative. Okay? So between zeros, we're entirely positive or entirely negative. Okay, so let's try another one. Okay, let's do f of x is equal to 3x to the fourth minus 4x cubed. Okay, so let's look at our left-right behaviors. We have an even function, even power. Okay, so when your power is even, then you go to that second category and you have a positive leading coefficient, so you know you're going to rise. Okay, so I'm going to put rise. That's just giving us an idea of what's going on each side of the graph, okay? Now let's go ahead and find the zeros, and we'll do that right here. We could take out an x squared. Wait a minute, this problem is supposed to be cubed, my bad. That's 3x to the fourth minus 4x cubed, so we're going to take out an x cubed. And that leaves us with 3x minus 4. Sorry about that. Okay, so we know that we have a 0 for this one right here, and that's multiplicity of 3. Because it's 3, okay, and then we have a 0 at 4/3. Okay. Now let's go over here and sketch a graph, okay? So at 0, 0, that's odd. Isn't that our 0 for the x cubed? X cubed is an odd power, so we know that right here, we are going through that axis. We are actually going to go through it. But at 4/3, okay, that's also odd, so that we're going to go through it at 1 1/3 too. Okay, so there's our zeros, and we know that we're rising on both sides, so we know this is going to come up like this because it's got to be rising. And then we've got to cross again right here. We've got to go down. And what you might want to do is you might want to plug a point in between there. Let's put a 1 in there, and you can use your calculator. At 1, this function is equal to -1, so we know we're right there. Okay? And then it's going to come back up and go through. You might even do 1.5 if you want to. Again, use your calculator to give you those values, and that's going to be at about 1.6875, something like that. Okay, so at 1.5. Then you're going to be up some, so you know you're above the axis there. So it just kind of makes a funny little curve right there and goes back up. Okay, so that's kind of odd. Look at it in your calculator and compare it. But that's how we take a polynomial function of higher degree and we decide kind of what the graph's going to look like. It's a little bit different. Okay, let me show you one where we're going to do a little bit of odd factoring. Okay, here's your function. F of x is equal to -2x cubed plus 6x squared minus 9/2 x. Okay, and this is something that we did in one of our sections in the appendix, but it's been a while. All right, let's do our leading coefficient test. We have an odd power, so we go to the category for odd. We have a negative leading coefficient, so we're going to fall on the right. Okay, and then we're going to rise on the left. So again, always check those right-left behaviors based on odd, even, and positive, negative. Okay, it gives you an idea of what's going to look like. So let's find the zeros, okay? What I'm going to do is I'm going to factor out a -1/2 x. Now then, remember, this is a good little trick to know, okay? When you factor out a fraction, remember when you factor, you're just dividing by the number that you factor out. So if we're going to factor out a 1/2, we're really going to multiply by 2, all right? So in this case, by -2. So if I factor out a -1/2 from -2, that's really -2 times -2, which is just 4, and then we're taking the x out, so that's going to be 4x squared. Then it's going to change the sign of our positive 6x to a negative, and that's going to become 12x. Okay, and then we're going to multiply the 9/2 times 2, and it's both negative, so that comes out as 9. Now we have something nice that we can work with. Okay, that's a perfect square trinomial. So here we go. We've got -1/2 x, that's going to give us a 0, and then you can factor that into 2x minus 3 because it's a perfect square trinomial. Okay, so you know that you have a 0, 0, that's one of your zeros. Okay, and it's going to cross, isn't it? Going to cross the x-axis right here because that x is odd power. So we're going across the x-axis there, and then we know that we have 3/2 0 for our other intercept. Okay, and there it's just going to touch. This is a multiplicity of 2 or double root. Remember, that's the same thing. Okay, and since that's squared, then we're just going to touch. All right? So here's our graph over here. Let's put our zeros on. There's 0, 0. We know we're going across right there. Then we've got 1/2, and we know we're just touching right there. And we're going to fall on the right and rise on the left. So it's going to come through like this, and we know we're going to cross right there. Then you've got to come back up, and you've got to touch right there. You're only touching, and then you're falling on the right, so it's got to come back down. And there's your graph. So these are just sketches, but if you know all of those details, then you're able to do it. Okay, here's our last concept, and what I want you to do is I want you to write a polynomial function with the given zeros. This thing is really hard to write on, I apologize. So I'm going to have 0, -4, and -5. Okay? Well, if those were zeros, we know that they came from x, had to be standing alone if 0 is a 0. And then we changed the signs, and we know x plus 4 had to be a factor. And then we know x plus 5 had to be a factor. And this wants the polynomial. So to find that's not a polynomial. That's called a product of factors right there that I have written. To get the polynomial, I would just multiply it all out. So I'm going to take these two and I'm going to FOIL them first. That's going to be x squared plus 9x plus 20. Okay, and I still have to distribute an x on that, and then I'll have my polynomial function. X cubed plus 9x squared plus 20x. And we have written a polynomial function with given zeros. So you just place those back into factors and then you multiply them out. It's very, very easy, not hard at all. And you can tell, you could do right-left behaviors, you could factor it and find the zeros, and you could find whether it falls, whether it crosses, so forth and so on. Okay, so now you're going to go to your packet and you're going to do the work for section 2.2. You guys have a good day.